Tukey, we had our first stage in H2O World was named after Tukey. And obviously, in fact, even in the earliest presentation we had for investors, we quoted Tukey straight, saying an approximate answer to the right question is a good deal more valuable than an exact answer to the wrong question. One of the things that the H2O World proverb was always start with the Grandmaster. Let me invite Dimitri Larko on stage, Grandmaster behind AutoDL, the genetic algorithm that evolves the features. And along with him, a small group of relentless individuals behind the scenes making driverless AI and our work in AutoML as good as it's happening. So Dimitri, SRK, should I call Matthias, aka Faron, Boyan, Marius, aka Casanova, Brandon. Is Mark Landry in the audience? I think he's not Grandmaster, but he's equally phenomenally talented data scientist for us. As you go about the next 2 days, you will run into them, meet them. There are more in the audience and more in the pipeline of teams we are building. So meet them, ask those curious questions on how these things really work. Dimitri, you want to talk about how the product has evolved since the first Jupyter notebook you put up trying to automate?
Oh, sure. So the whole Driverless AI project actually been started last March, and basically it has been started as a one Jupyter Python notebook. So basically, thanks to the team, we have extremely experienced software engineers who was able to convert this Jupyter notebook into something you can use actually and you can learn about today. Obviously, I'm just as I wasn't able to do anything by myself, basically. The whole team actually put a lot of efforts to create a product which you can actually see today. So SRK works on text analytics and NLP stuff.
How many of you use Jupyter? So all great things starts with the Jupyter notebook.
Yeah.
Right?
So Matthias and Marius help us with time series. Boyan, who recently joined, is going to help us with unsupervised learning. And Brandon, yeah, your advice was always, yeah, you're not a part of the Driverless AI team, but your advice and always was helpful to me, so thank you.
SRK, talk about NLP.
Yeah, so I joined like H2O about 8 months back, and it has been a fantastic journey so far. So I'm working on the NLP side of things with Driverless AI. So yeah, I have a talk tomorrow as well. So please feel free to reach out to me anytime. Like I'll be outside. So yeah, thanks Sri for the wonderful opportunity.
SRK is our first hire in a continent of people, or subcontinent of people in India. So we opened our India footprint with SRK, and since then our growth has been phenomenal in terms of both followers and users of the product. So thank you.
Thanks.
We knew Matthias mostly as Faron, and he's always been prolific in his work. I think has Driverless AI taken away bulk of your Kaggle time?
Oh yeah, definitely. A bit. So it shifted a bit from putting time into Kaggle into developing Driverless AI, because it's in a sense the same challenges that I'm facing there. But first of all, I want to welcome everyone here, and for me it's especially exciting to see that I think it's my third H2O World right now, and every time it's getting bigger, and I'm seeing more faces in the audience, and yeah, so welcome. I hope you will enjoy the 2 days today.
Time series is crucial for data science, pretty much as we know it.
Yeah, and as you like to say, like the whole life is a time series in a way. So we, I mean, Driverless started out with the focus on IID data sets, and of course it's a huge amount of problems that can be solved this way, but time series is, of course, another big one, and yeah, we are constantly developing into that direction so that we are not only able to solve IAD problems or also time series problems and NLP problems, unsupervised problems. So that's a whole package gets available to solve a lot of different kinds of problems, basically all the kinds you can face as a data scientist.
Thank you. Boyan is one of the top-ranking grandmaster, fastest growing grandmaster in rankings in the United States. Is that?
I think I'm currently highest ranked in the United States, but that doesn't say much. So I'm actually the latest addition to the Grandmaster crowd over here, and it's been actually very exciting for me to even be in the same room, let alone the same stage with some of these people that I admired and looked up for years. And I'm really excited to learn from them and share some of my insights and bounce ideas from them. So it's been very exciting. I'm currently contributing, as Ashri mentioned, to our effort to expand our driverless into the unsupervised learning. This is one of the topics that actually we Kaglers don't deal much with because it's all about making best predictions. In unsupervised, you don't really deal with much with that. However, in industry, from what I've experienced with some of my previous work, that's a very important topic. You do want to understand data sets. You want to understand your customers better than what you otherwise would be able to do. So I've come up with trying to force some of the supervised techniques to be co-opted to try to make some better understanding of the data sets that we have. So in addition to like interpretability that we already have and great visualization tools, hopefully this unsupervised techniques can be another thing that you can do with driverless in the future.
Unsupervised learning is definitely one of the top, most frequently requested item in driverless. So look forward to that. By the way, you're not the newest edition. I think Babaken joined recently. I don't know if he was able to make it. And we have one more who has accepted and not yet joined, and starts in March. So there's a few more in the hopper with newer recipes. The driverless AI architecture is recipes, and we started with the first recipe from Dimitri, and we're steadily adding more recipes to solve different problems. So Marios, you've spent the bulk of the time taking this to customers and getting their feedback and getting back new algorithms. What has been your experience so far, and also your work on time series and StackNet?
Yes. So first of all, I have to say I feel really humbled to see such a packed room. It's been amazing to see the growth. I've been now with the company like 1 year and a half, and the support and the love of the community has been overwhelming. So thank you very much for coming here and showing your support for what we do. I think I made a small transition last year. Initially, I used to work quite a lot with the software, but I decided I wanted to see how the customers are actually using the software, because sometimes looking at the tree, you might miss the forest. I mean, all of us who have very good technical skill set, but we want to make certain that what we do translates and can be useful to the end user. And it has been a great learning experience. Much of the focus for the things we're going to do is not only to add new recipes and make certain that you get the most predictive tools out of driverless, but also make certain that you can integrate it to your end-to-end processes, you can productionize your models easily. So principles that were always part of the H2O, we will make certain that they get transferred to driverless AI as best as possible. And it has been great experience to see actually driverless being productionized and getting good results. It was a privilege to be part of this process. And there are some good things coming on time series, but maybe we will talk about it on our relevant session. I don't want to monopolize it. So again, thank you very much for coming here.
One of the things you'll realize is a large part of H2O and especially driverless AI makers want the product to do the talking, as well as much as we would love to explain how it's working. Brandon, talk about your work with OCR and documents and how to make sense, kind of the Brandon's working on an invoice to vector automatic transformation, and your work on Torch and other places.
Yeah. So what I'm working on now, I don't work on driverless like all these guys do, but work for a project for a customer where we are currently trying to read business documents and invoices and stuff like that, and then make sure they match accounting records. So yeah, we're using a lot of some deep learning stuff right now, some NLP stuff, trying to find tables in documents, trying to find invoice dates, invoice numbers, and stuff like that. And our hope is one day that this may become something in driverless, but that's probably at least a year away, I'd imagine. We have to finish the project first, and then we'll see what we can get into driverless.
OCR.ai, right? Well, I think we've a fantastic compendium of work the rest of the day, and Grandmasters are back on the closing day finale, the Kaggle Grandmaster panel. We'll add more folks from the audience as well. So I think, spot them on the floor, grab them for coffee, and get as much feedback throughout the day, or most of your questions answered as well, and strike up a conversation. We don't know what will happen. So thank you so much.
All right. Well, that was amazing. Great team. Every time it's humbling to be part of such a great team, and it's only getting better. So let's get our hands dirty with the product. Who has been able to launch an instance? Raise your hands, please. Okay, that's a lot of people. So let's try to see that you get to this point here. If you have problems logging in, ask your neighbor or raise your hand. Someone else will help you. Not too many, that's good. So what you get is you get a link at the bottom. You click on that link, and up shows driverless. Now you have to copy and paste your license key in there. Do you have a license key? No. Well, you have to get one. Okay, let's see. Here is the license key. Go to bit.ly, dive into H2O. That should get you to a Google Doc that has a license key. So just copy paste that into the top line of that other page where it says paste license. Has anybody been able to do this? So bit.ly/dive into H2O. Not H2O, by the way, it's H2O. There's no 20 hydrogen molecule. This is also H2O, so remember that well. It's raining today. So let me check that it works. So you copy this whole string, the whole thing. It's okay if you have the last space or not, doesn't matter, but I think you just copy the words, the one long string. You copy it, You go to the product at the top and say enter license, and you put it right there, okay? At the very top. Don't paste it at the bottom, paste it at the top, the white license key placeholder. I'll show the URL one more time, bit.ly, dive into H2O, okay? Here we go.
Yeah, just stay there for a second. Has everyone, I think there's some slowdown in the internet you're seeing as well, so just give it.
Who is not ready yet, please ask for help. Then I'll start with the product demo, the hands-on. So whoever has been able to type this in there and say save, then it will say, all right, your license expires in 2 days, so at least you have a little bit of time left, but this instance will shut itself down in a few hours, so you can reapply for one. Use the same license again if you want to play some more in the coming days. Just get familiar with this product. That's the goal right now. So you don't have data in your folder here yet, so we have to add data, okay? So you'll all click on this right top where it says add data set. And at the top, there's a bunch of tabs that you can open. So one is data sets, one is experiments, one is MLI, Autoways, and so on. You want to make sure you're on data sets, and then you say add data set with the flashing yellow at the right. Then you go to file system, the first one, and then you have to go to a folder here. It probably will look like this for you at the beginning. It will show you the root file system. You go to data, Kaggle, credit card, and you click on both these checkboxes. You can now import multiple individual files at once. Data, Kaggle, credit card. And then you say, click to import this selection, okay? And it'll tell me, yep, I already did that. So I say, okay, fine, do it again. You can also delete data sets if you want to clean up a little bit. So you want to make sure you have train and test credit card. Who has that? Can you raise your hands? All right, perfect. So now, let's visualize it. So we click on it, and we say visualize. This will now run all the statistics, and then you click on it, and then it shows you the visualizations. Now, what is the credit card data set, you might ask? Hopefully you ask. That is a data set that's on Kaggle, our friend in this endeavor of going through data science and learning about data science and workflows. So this data set has 25 variables, mostly related to whether or not you paid in the past, but also some other things like gender and age and so on. It's more like a demonstration of a data set that could be useful, but I mean, we're not saying this is what people should be doing. It's just, this is just a data set that might make some sense to look into. Then the outcome variable is the one at the very bottom, whether or not this person defaulted on their payments in the next month. So we want to predict, will they default from what I know right now? And every person looks roughly the same. There's no time series going on. It's just a record. You know who you are, how old you are, how many times you paid in the past. So they already aggregated all that. They said, how much did you pay in the last month, in the last 2 months, and so on, right? These are the descriptions here. If you want to search for it, type in Kaggle and credit card default or something. But you don't really need to do that right now, unless you want, of course. The goal is to run an experiment now. So I click on it. Oh, by the way, the visualization that we have is always available here under Autoways. So you can go back inside anytime you want and go look at it. So for example, I can look for outliers, and I can see, oh wow, somebody had a huge bill amount. But maybe that's okay, right? Because it's only $1 million. We're here in San Francisco, that's nothing, right? So it's not really an outlier because it's consistent with your, oh, it's this. Maybe the license, what happened again? Did the license expire? Sorry, I need to do it again, I guess. There you go. Did it not take my license? No, but it says enter it again. It's okay? Okay, good. I just want to make sure it doesn't cause trouble. Okay. I ran some experiments earlier, as you can see here. It did finish. So who's able to run experiments? No, you shouldn't know yet. You haven't done that yet. You only did visualizations. Okay, great. So who did visualizations? Great, great. All right, so let's go look one more time. So this is the correlated scatter plots and so on. So you can just browse through it. And I always go back there. Terribly sorry, I don't know what's going on. There must be something with my instance. Let me see. Does anybody else have this problem? You all get that error? Does your license work? Does it pop back up? It also pops back up. Maybe somebody can, you can X that out, yes, but if you do a refresh, it still shows up again, as if I didn't get it. So maybe we should get a different license or something. Maybe somebody can check that. It didn't happen yesterday when I tried it, and this morning it also wasn't happening. So we'll see. All right, so let's run an experiment. We go to train, and we say predict. And under predict, we'll pick a target column. And we said we wanted to predict whether or not this person will default. So we'll take the default column, and we'll say basically go. But this might take a little too long because we only have a small instance with 4 cores, so we don't need to do the default settings. We can turn down the accuracy and the time. So I usually just, for demo purposes, I'll just crank it down to 1.1, and we can leave it at 6. And if I say go now, it will just fit the model to predict default. Now, at the same time, we can run another model because you're maybe curious what happens if you change the interpretability from 6 down to 1. Maybe you don't care about interpretability at all. So we can go back to experiments. While this is running, we click on this experiment. On the very right, there's 3 yellow buttons. You click on that, and you say new model with same parameters. And that basically uses all the settings that you had before again. So you can run another one like it. But of course, you want to change a little bit, otherwise you'll get the same outcome. You won't exactly get the same outcome because the reproducible button is not set, by the way. There's a button in the middle here under time, which says reproducible or not. So this determines whether you want to set the seed yourself or whether you want the random seed to be random. And usually we leave it to be random. That way you get some more variation between your runs in case you're interested in seeing how good a setting 1 is, for example. Because accuracy 1 really means I really don't care too much about accuracy, which means we will do 1 split, training validation split. But next time you run the experiment, it's a different split, unless you set that seed, that reproducible button. So if you don't set the seed, every time the split will be slightly different. If you run 5 experiments and they all give vastly different results, then you know, oh, whoa, this accuracy 1 really is not enough. But if you run 5 and they're all the same, even with accuracy 1, you can say, oh, that seems like that's enough to have an estimate of how it's going to do. You still don't know how it's going to do if you did accuracy 10, right? But you know at least accuracy 1 is basically always the same. So now, let's run one with interpretability 1. That means I want all kinds of crazy features. Now, what does it mean, crazy features? Well, you can see on the left side here. I know it's small, but you have a screen yourself, right? You can look at the left side in the preview, which will tell you a lot of things. One of the things at the top is how big is a data set that is going to be used for training. Let's say you have 100 million rows, and you set the accuracy to 1. It will say, well, I only use 5 million rows, or something like that. It will not use all the data, because you said you don't want high accuracy. So we'll tell you what we'll do to make it work the way you want it. So you turn the knobs and you look on the left side. That's really what we encourage you to do. Now, the data set size is one thing. There is also a a possibility that the data set that's used is further downsampled for the feature evolution part in the beginning, because we make a lot of experiments, as I said earlier, to figure out what works and what doesn't. So this could be done on a smaller sample, and at the very end we use more data, because once we know what to do, we can do it on the full data set one time, right? But the full data at the end might not be all the data. Let's say you have 100 million rows, you could do this on only 10 million at the end, because you had accuracy set to 2 or 3. So you get a kind of a feel for it if you turn the knobs. Everything is described on the left, but the actual feature evolution, as we call it, could be on a smaller sample. It could be 1 million rows. And the final model could be on 20 million rows. So it's not always training every little model on the whole 100 million rows, right? That would not make sense, because you don't need to figure out from the whole data every time whether this interaction means something or not. So we have these techniques built in to make it fast and accurate at the same time. And all the tricks that we do are exposed to you, so you can control them. You can also configure them in the expert settings. You can click on expert settings, and you have a lot of options here. You can pick which models should be included. You can pick what kinds of features should be made. You can click on what size data limits should there be. When do you consider that a string column a text? You know, these kinds of things. So they're all statistical nature usually, and they have to do with some heuristics that should trigger certain recipes, if you want. There is a recipe that will drop columns if they are too different between training and testing, and you can turn that off or on. You can say, for example, I want to create a model that has only 5-way interactions. I don't like 8-way interactions. So the default is 8-way interactions. And that helps a lot for that Kaggle problem I mentioned, where we got to the 10th place. But sometimes you don't want 8-way interactions between columns. It's too much, right? You want to explain it to somebody, leave it at 1 or 2-way interactions. So you can manually control all that. So let's run one with 1, 1, 1. And if you go back to experiments, you can see that the 116 one that I ran earlier is done. So you can click on it. And what you'll see is a evolution over time on the left side. This is the validation performance of the model. So the model measures its performance on a holdout data set over and over again. And that data set is a split that is determined up front. So it could be one split, or it could be multiple splits. For example, you could cut up your data into 10 pieces and then do 10-fold cross-validation. And then the average of the 10 different fold scores are shown on this screen. Or it could be just a single split, like a 70%, 30% split, and then the number on the 30% is shown. But it's not really the number on the 30%, it's a number that's obtained from the 30%. So there might be 50 repeated scoring runs on the 30% with different views of that data set, of that 30%. And that average distribution, mean and standard deviation, that is shown there. So there's error bars on the left side in these charts. And the error bars give you some kind of an idea of how crazy is this data set, right? Is it consistent within itself, or are there lots of outliers? Now, in the middle, you'll see the variable importance. And as you go left and right on this chart, you can see how variable importance changes. So sometimes it's simple features, like here in the beginning. They were all original features. And then after a while, we came up with some new stuff, some interactions, one-hot encoding or whatever. And then suddenly, it's a little bit better. Now, this is a model that's quite interpretable. So this is a GLM that has basically just raw features with some one-hot encoding. So it should be easy to interpret later when Patrick comes up and explains to us how we would interpret this model using MLI. However, I also run one with 111. And that actually is probably a little bit more accurate. Now, how do we know how accurate it is? We only have an estimate on its own holdout set that it says, I think this is going to be a 0.77. In this case, it's AUC, because that's what the default was for classification. Here on the right, you can see the scorer. We didn't touch that when we said run. But the 80.77 or so AUC is obtained on the training data on the holdout split of the training data, right? Which means we think this is how well it does. But we can only tell from our training data that you gave us. How am I going to know how it's going to do tomorrow? Well, you can give it a test set. So you can start an experiment from the beginning. You can say, I make a new experiment, or you can repeat this one again. I like to use this model with same parameters, and I like to pass a test set from the beginning. So at the top right, it says test set. You can provide a test set. Now, the only difference to before is that we have the ability to compare training and test distributions and say, oh, whoa, this is fall versus spring. This is not IID. This is not identically and independently distributed. These are like actually totally different. So we should drop the column that says how much sunshine there is or something. But that would give away too much. It wouldn't be a good model because it will memorize the time, for example. It will not know about the actual data. So if you give us a test set, we have that option to drop some columns if they look too different. But we're not doing anything else. We're not cheating. Now, if you take that test set into play, you will get a score at the end on that test set as well. But we're not training on that data set. We're just learning distribution shifts. And those you can actually disable in the expert setting. If you disable the distribution checker, then there's no difference to whether or not you give the test set. So now that we gave the test set, we again have a 78, because that's how we think we do when we do 1, 1, 1. However, there is also a test score at the bottom. And that shows us it's 0.79. So we're a little bit better on the test set than on the validation set. So it means the new test set is a little bit easier to predict. Maybe fewer outliers or small data sets, you got lucky. There's statistics, right? The error bars are quite big. Now, you can diagnose this model on a new data set. So you can always bring in a new data set. I'll use the same test set again, but under diagnostics that you also can get from the top here, there is the option, let me show you again. So when the model is trained, you click on diagnose this model on another test set. So that's here, diagnose model on new data set. So you can bring 10 more data sets from the fall, from the winter, from whatever, and say, here, look, how is it doing? And whenever you do this, I can go back to the diagnosis screen because you just made it. Now I can look at the diagnostic, and you can see all the different charts that you would want to know. ROC curve, precision recall, gains and lift charts, KS charts that basically show you the difference between picking up the right guys and the wrong guys at the same time. So you want to see how much do I get the right guys more than the bad guys, so to speak, right? The correct predictions versus the false predictions, the true positives versus the false positives or the true negatives. So it's really a balance between saying, yep, I found it versus...
Can you show the audience how you got to the screen again? I think a lot of them...
To which page?
The diagnostic.
The diagnostics page, yes. So you go back to the experiment, and you click this button here that says diagnose model on new data set. You can also do it from the diagnostic screen itself and say diagnose model. And when you then diagnose model here, it's the only thing you can press at the top right. It's always at the top right to start something. You can then pick an experiment, and you can see the name of the experiment. So you have to sometimes remember some of these 8-character long words, and we just make those unique identifiers so you don't conflict with each other. There's also a projects page coming in the next version, which we are alpha previewing right now. So if you're interested in the projects page, please reach out to us, or let me show you. So we have a projects workspace. And the projects workspace will allow you to, did we have any experiments yet? No, nobody ran anything. Okay, I'll show it to you later. But you can imagine projects, there is the ability to compare different models and then have a leaderboard. So that's something that people have been asking for, and we're working on that so that you can get the features you request. So another thing that's really cool is the deployment, the single-click deployment. It's also available. You just have to, basically the experiment's done, you push the button deploy. Now for that you first have to build the Mojo scoring pipeline. So you click on the Mojo scoring pipeline. This is a Java standalone package, and now you can actually deploy that. But if you deploy it, you have to type in some S3, AWS credentials. So if you have those, you can try to deploy your model as a Lambda endpoint, which is basically a single-click deployment option. Now I think, Patrick, if you want to show MLI real quick, now would be a great opportunity. We also have time series. So if you have time, after you show MLI, we'll launch a quick time series experiment as well. So the point is that if you go to interpretability 1, you get all these crazy features here at the bottom. Sometimes you see numcat encoding, SVD, truncated SVD. Sometimes you don't. So it depends on the experiment whether or not it picks up something crazy. If you have something crazy, then you can turn down the interpretability knob to get to something more easy to understand. See, this one is one that's crazy. It has cluster target encoding, 8-way interactions, out-of-fold means, and division of pay 0 over pay 2, and all these features. Many people say, oh, that's too crazy, I don't want it. So I don't want interpretability 1, I want interpretability 10. And then it looks much easier. Then it's only the original features. And if you now do MLI, it will actually make sense. So do you want to use your own laptop? Okay, great. When you're done, we can do time series. Okay. Thanks.
How many of you have created at least one experiment? The few hands that haven't lifted, we probably will come by and try to help if you need. I think the next phase of the hands-on session, I would hope to see as many of you give feedback on explainability after using it. So.
Okay, so we have a little kind of guidance for this part of the tutorial. And I know that one person can't go to Bitly, but I think everybody, or hopefully most people can go to Bitly. And where we'll pick up is assuming you've already trained the credit card model. So you don't have to do these first steps. We can skip down. This is what we just did. Yay, we trained an automatic machine learning model. So if you have a model trained, we're going to click on interpret this model. And again, let me show the Bitly link one more time. And we're going to start in section 2 or 3 of this outline. And it's kind of guided. You don't have to listen to me. You can follow the outline. You can do what I do. It's up to you. I'm going to try to follow the outline, though. That's fine. Oh, of course. Give me a heads up when you think it would be good to get started. So the idea is that Arnaud led you through training a model on the credit card data. And obviously it's a fairly simple model. We didn't let it run for a very long time. But we're going to click on interpret this model. Who's able to do that? Yep. Where'd Ashworth go? You think I should start or wait a little bit longer? Yep. And again, I saw most of you train a credit card model. So once you have the credit card model trained, after that's trained, you should have the option on the modeling screen to interpret this model, and that's where we're going to start. Okay. Okay, so people can't see the tutorial? Yeah, they can see it. Okay. Oh, it's case sensitive. So we had an audience comment that this is a case sensitive link. Okay, so we're going to pick up at interpret this model. The bit.ly page doesn't work? Ah, okay. Okay, we can just start. We can just follow along, and we'll make sure that this link is available so you can come back and look at it. Okay, so back to the software. And now my internet is slow also. I've got a couple different options I can try, though. Yep. So who was not able to see the tutorial? Okay. So if the TAs could help people get to the interpret this model option and click on that, I'm going to try to change my internet up here. Okay. I can't get anything on my screen now. What's that? Yeah, sure. Or the hardline internet.
You want me to get you the hardline?
Yes. Let's see if that does that.
Yeah, I'm gonna disconnect them real quick. Just to let you know.
We're going to interpret this model. So what's going on while this what's going on while this dial is turning? we're doing a lot of the calculations that we need to do to build the dashboard that we'll use to interpret the model. And basically, we're rescoring the model many, many different times. So a lot of the techniques that we use, just plain old-fashioned random forest or gradient boosting, variable importance, Lime, Shapley values, partial dependence, all of these things involve rescoring the model over and over and over again. So that's what's happening while this system is turning. Who's able to get here? Okay. Please. Nope, not retraining. So that was a very good question from the audience. What we mean by rescoring the model is running the data back through the trained model, either the entire data set or row by row, and we do both. To get the predictions. And a lot of the techniques, and this isn't just us, this is everyone kind of in the interpretability field, a lot of the techniques are kind of like, I'm going to change the value of a variable and rescore the model and see what happens. So this kind of fundamental concept of what if is very important when we're trying to probe how these quote unquote black boxes work. So I might change, the prediction for one of the features and run it back through the model and see what happens. And we're going to work through the way the tutorial outline works, and what I'm going to try to accomplish is this idea of starting with the main drivers. So we're going to look at the global Shapley feature importance. And then we're going to move on from there and look at the partial dependence, how those variables behave. And then we're going to try to get an idea of the interactions with the decision tree. And then we're going to dive into what drives this behavior locally. So you can see some of the techniques that we're going through with names like LOCO and Lime. So LOCO stands for leave one covariate out. And that's this idea of, again, changing something in the model and then seeing how it impacts the prediction. Leave one covariate out. So I try to leave a variable out of the model and see how the prediction changes while I've removed that variable. Lime, again, stands for local interpretable model agnostic explanations. And that was a very popular technique that came out in 2016 where we try to fit a linear model to the predictions of the complex model and use that linear model to reason about how the complex model is working. Yep, please. We do sample sometimes. We do sample sometimes. But the reason we have to go row by row is because we want to know for every row why the model behaved the way it did. But we'll typically start out on a sample. Okay, so it's never taken that long before in my life, but finally we're here. So again, I think the pattern that I want people to get used to here is trying to understand the main drivers of the model, trying to understand how those main drivers behave in the model, trying to understand how those main drivers interact, and then digging into, hey, for this one person, why did the model make the decision it made? And there's some basic information here. What I find particularly helpful is the data set I used and what I was trying to model. So we used the credit card data set, and I'm trying to model default payment next month. Here we can see the importance of some of the features that driverless AI derived. Now, if these features get very complex, obviously that can be an impediment to interpretation. And we have to come up with a way to work around that. And that's why you'll see some of the techniques are done on the very complex variables themselves, and then some are done on the original variables. And what you're seeing here in the middle is a table of the models that we use to go between the original inputs to the system, down here, and the predictions of the driverless AI model. And we call those surrogate models. So that decision tree that I showed you earlier is actually a surrogate model, and we'll come back to that in just a second. Okay, so the first thing I like to look at is these Shapley values, the global Shapley value. And the interpretation here is on average, so on average, this one hot encoded variable of pay 0 equals 1, so someone being 1 month late on their most recent repayment status, on average, that contributes about 0.28 numeric units in the logit space. Okay, this is since this was a classification problem, these numbers are in the logit space. So keep that in mind. So but the interpretation here is this variable on average contributes about 0.28 units in the logit space above the average prediction. So this variable is associated with people being more likely to default on average. Down here we can see a variable that is associated with them not being likely to default on average. And then the number is actually the average numeric contribution of this variable to the prediction offset from the mean prediction. And in this case, because it's a classification problem, it's in the logit space. And if that's all too much for you, which is fine, the big bar going right means it contributes to people defaulting. Big bar going left means it contributes to people not defaulting on average. Okay. Now, I like to dig into the partial dependence. And so this is the average behavior of the variable in the model. And some of you may know that partial dependence isn't perfect, and we have some additions to this plot that hopefully you'll be able to see in a few minutes. But it's a good insight into how the model treats this variable on average. So that I can see these values, -1, -2, 0, those all correspond to either paying your bill in full or paying your bill on time. And so we see a low probability of default for those values of this variable pay 0. Okay? So pay 0 is someone's most recent repayment status. And basically, when someone has had a good recent repayment status, we say, they're not very likely to default. But as someone's most recent repayment status climbs, and these higher numbers now refer to months late, so if someone is 1 month late, 2 months late, especially as a big decision point, so if someone's 2 months late or above, we give them a fairly high probability of defaulting, about 0.35 on average. Okay? So now I know that this variable, pay 0, is an important variable in my model. I saw it occurring here. I saw it occurring here, here. And then I can go and double check this in the original feature space. Pay 0, very important. Now this chart is more approximate, but I can still say that pay 0 seems to be much more important than the other variables. Now I'm getting some idea of how pay 0 is being treated by the model. Yep.
Bunch of questions popping up on Slido.
Yep.
Feel free to make this as interactive as possible. Obviously, you've had some advantage of the interactivity of hands-on. Since you have most of the maker community in the audience or on stage, it's best to also poke around and ask good questions.
Sure. So there's a really good question down at the bottom, very technical. I like it. So can logit chat values be transformed to probabilities? This is an issue for XGBoost. Is it also an issue for LightGBM? What I know is that there's the Python chat package, and in that chat package, and I think also in XGBoost, you can now very recently get the direct probabilities as opposed to the numbers in the logit space. I don't know so much about LightGBM, but that's a very good question. So I think that you should be able to get them as direct probability soon, and hopefully that's something we'll incorporate soon. And what is the loaded space? The logit, L-O-G-I-T. So that is the raw numeric outcome of the model before we make a classification decision, yes or no. Oh, there's a question about interpretability and explainability. I like that. So people are still arguing about these terms, right? And I'll say that people seem to treat interpretability as an umbrella term. And under interpretability, you might have explanations, like we're doing right now, sort of post hoc explanations. Or you might have things like model debugging, which we've talked about. And then sometimes when people say interpretable, they mean a directly interpretable model, such as a GLM or a decision tree, and some newer variants of machine learning models that are themselves interpretable. But in general, these terms are still being argued over. Explanation is kind of becoming something that people do after the model was trained, but that's not even necessarily true all the time. Okay. I've looked at the main drivers. I've looked at how one of them behaves in the model. I can pick some more. I can click on other ones. You probably want to look at them all if you were being serious. Now we want to look at how they interact. So this decision tree. And I said something like this decision tree is a surrogate model. So what does that mean? Surrogate models are helpful explainability tools. They're certainly not the end-all, be-all of explainability. They're just helpful tools, and they can fail. In this case, I would say it's a very helpful tool because we can see we have a high R squared and a low RMSE. Okay? So what these two numbers are telling me is this decision tree that you're looking at is a decision tree that was trained between the original input variables and then the predictions of the driverless AI model. Okay? So we're building a simple flow chart for how the driverless AI model makes its decisions. That's how you can think of this decision tree. And you can build it deeper if you want. If you build it too deep, though, then the decision tree itself could be hard to interpret. right? So we try to compress the volume of information. What can we see on this decision tree? The thickness of the line, that is the most common path through the tree. Okay? And we can see this kind of makes sense that the most common path through the tree is a fairly low probability of default, right? That's how the credit card company stays in business. Most people pay their bills. What else can I see? Well, here's this split. So pay zero, someone's most recent repayment status. So -1, -2, 0, 1 go one way down the tree, the low probability direction down the tree, and then greater than 2 goes the other way. So does that remind you of anything else that we've seen? So you want to see this kind of confirmatory information, right? So we can see there's a big jump in probability of default at pay zero, someone's most recent repayment status equals 2 months late. And you, as the business analyst or the data scientist, you need to decide, is that okay with me? Does that make sense to me? Does that make sense for my business? And if it doesn't, you need to consider going back and training a different model, trying to remediate this problem somehow. Okay, I'm going to answer some questions. Is it possible to run MLI models generated outside of driverless AI? Yes, and you can do that with the new interpretation feature. Okay. All right. So we're definitely calculating variable importance in a non-parametric way. Okay, so back to the decision tree. So when variables are below one another in the tree, that points to a potential interaction. So now I'm starting to see how the main drivers in my model are interacting. Okay, and if I want, I can build the tree deeper and see even more potential interactions or more specific local interactions. So again, you can think of the decision tree surrogate model as an approximate overall flow chart of how your model is making its decisions. Okay, so to summarize again, we saw what some of the main drivers are. We saw how one behaves on average. We're starting to see how they might interact with one another. And now what I like to do is I like to look at our implementation of LIME, again, surrogate model, model of another model, simple model of a complex model. It's not perfect, it can fail. But in this case, you can see that our surrogate model did a really good job approximating the driverless AI model. So in this case, what this plot tells me is we've basically trained a linear model. A linear model explains 98.37% of the variance of the predictions of the driverless AI model. Sometimes you won't see this, right? Sometimes you'll see the driverless AI train extremely complex models, and you'll be able to see in this plot, oh, a linear model only explains 30 or 40% of the variance of the driverless AI model. But because of the settings that were used to train this model, we came out with a very linear model. Now, this is where we zoom in to local. So we've been talking about globally, how does my model work? Now we want to answer this question of why does my model make the decisions it makes for each prediction? So I'm going to pick a person. If I was a data scientist at a bank or a business analyst or something, I would probably be interested in one of these really high probability of default people. So I'm going to click on that. And then I'm going to immediately go back to Shapley. I'm going to come back to K-Lime if there's time. What I found is that these surrogate models are actually pretty advanced techniques. And it's actually easier to look at Shapley, which operates on the model directly. Okay, so the Shapley values model operate on the model directly, and what we're seeing here is confirming what we saw in the K-line plot. Our model is very linear. Okay, so the local effects are almost always equal to the global effects, and that means that we have a linear model. Let's see if I can just show you a different example. Okay, so now we have a much more nonlinear model. And this is what you would see if you had trained a more complex model with driverless AI. You can see how the gray local feature contributions are now different than the green global feature contributions. And this changes row by row. So I can pick another person, go back to Shapley, and it's a little bit different. If I pick a low probability of default person, now we can see the Shapley values have changed again. Okay? So I want to take some time to focus on these Shapley values and get to some of the questions that I see. So, as I mentioned earlier, we have a lot of excitement around this particular calculation. And the idea is that these gray bars will add up to the model prediction for every single prediction, okay? So whether it's a regression or a classification problem, we can break down any prediction, any arbitrary given prediction, into its components by each input variable, okay? And these contributions are theoretically guaranteed to be locally accurate, okay? And again, I want to emphasize, people ask if we should trust Shapley values, and I mean, he won the Nobel Prize. I don't really know what to say. I actually didn't know that. I talked to people about Shapley values for like a year before I knew that he had won the Nobel Prize in 2012 for it. So it's an idea, it's an old idea from the 1950s, like a lot of things in machine learning. It's an old idea from the 1950s from game theory that we apply to machine learning models. And the original Shapley value was meant to tell the contribution of a player in a coalitional game, so a game where people can cooperate. So now we've mapped that idea over to machine learning models where we know the variables interact in complex ways, but we can still get their exact numeric contribution to every single prediction. So this is local variable importance that changes row by row by row by row through the data set. And this is why we need to calculate, this is why we need to score the model so many times. I'm going to have to come back to some of those questions. And please, if you have a question here that I'm not answering, please follow up with me after the tutorial. Okay, so now, and I want to emphasize, we can generate these values both in this dashboard, and we can generate them outside of the software. So we can generate them in something kind of like real time. Shapley values are very expensive to calculate, and so I wouldn't go so far as to say we can get them in real time yet, but we'll probably figure that out. But we can get them in something close to real time for production applications. So you can click through line by line by line. That's probably not what most people are interested in doing. What most people would be interested in doing is having some kind of public-facing web application, and it makes a prediction that a customer would be potentially interested in, and then it can tell you why. Why didn't you get the credit card? Why did we show you this ad? Why do you think you like this music? So these are exact descriptions of why the model makes the decision it made in in terms of the local variables. And I'm going to let Arno come back up and talk about time series, but before I do, I just want to show, this is one of my favorites. It's definitely information overload, but we have this dashboard where I can kind of click around and find interesting things potentially. So I can see all of the information at once. I can see the LIME, the local linear model feature importance, which is the model coefficients times the values in the row. And that's, whoever's asking this parametric question, I want to talk to you later because we do it in so many different ways. We can see the feature importance. We can see how this row moves through our decision tree. What was the decision policy enacted on this individual? And we can see, the one thing that we haven't talked about is this ICE value, these white dots that you see right here. And this is a single individual being rescored by the model while we change their value of pay zero. So this is, again, like one of those what-if scenarios. I changed someone's repayment status, and I see how the model reacts. And what can I learn from that? Okay, so I'll leave it here for now. We're going to be at the booth the next 2 days, and I'll be around. The team will be around, so please let us know if you have further questions. And I'll let Arno come back up and show some time series.
Thanks, Patrick. This was a great detailed introduction to MLI. Please play around with it, ask questions. That's why you're here for. There's a lot more in online documentation that you can download. There's booklets. There's also tutorials. Go to GitHub, H2O AI, tutorials. There's a tutorial for driverless AI itself on a Titanic data set. There's MLI tutorials. There's H2O3 tutorials, all kinds of tutorials. So if you want to take a screenshot of something, this is the page, or a picture. This is definitely a good place to go check out stuff. But even better, ask us. We're here, right? Ask us on Slido. If you show me Slido questions, I will be more than happy to answer them. People ask, do you need GPUs? No, you don't need GPUs. Everything that we've shown you runs with or without GPUs. GPUs can make it faster, in certain circumstances a lot faster, but you actually don't always need GPUs. For example, for NLP, TensorFlow only adds a little bit in most cases. You can do count-based features that I mentioned earlier, and these are super fast even without GPUs. For gradient boosting, GPUs can make it maybe 5 times faster, so it really matters to some people, but if you have no GPUs, then you're much better off getting driverless into use than not having it running, right? So you want to make sure that you have a data set in mind. Think about the validation scheme. How do you know this data set is going to give you a good model? Well, how do you know the model is working? You need to test it on something. So what piece of the data do you give for testing? I showed you training and testing, but there's also a way to pass a validation frame. So there is a third option to do models, and that's by passing an actual validation frame. So let me show you that. So let's say I make a new experiment. I could pass here a validation data set. And what it means is we will score on that frame how the model does that was trained on the training data. We won't make our own internal splits. You say this is fall training and spring validation, and you give us those two. Then we'll make the best model on the fall that will do as well as possible on the spring, right? So if you have those kinds of situations where it's not all just similar rows, they don't depend on time or anything. If it's actually time series, then it's even one more step ahead. So this validation frame is good if it's slightly different, but still kind of the same. If it's really different, like time series, let's do a real quick start of time series. I know we only have a few minutes left, but it's still good to think about that. So I'll go to add a data set for time series. So on the data at the bottom, it says time series, and there is Walmart also at the bottom. So data, all the way down time series, all the way down Walmart. And I'll take the two ones at the bottom. Train and test, small. Now I can say predict on train. What do I want to predict? I want to predict the weekly sales. So this is a store data set where every store and every department of that store has a sales number per week in all of the Walmart stores in the US. So you have historic data, and now you want to predict sales. Now, ideally, as you know, there is a time series for each store and even in each department too, right? So you have whatever food in Walmart in Chicago, that corner of the city, and then there's another toiletries and a similar one in like Wisconsin or something. So it's all different time series. Now you have these hundreds or thousands of time series, and you want to predict for a new store that you maybe never ever saw before what's going to be the sales in toiletries. And Driverless does that for you. So just imagine you using this tool or not, it makes a big difference, right? So use this tool if you can. And whether it has GPU or not is not the problem, let's say, or whether or not you have an instance with 600 gigabytes of RAM or not doesn't matter either. You can do a lot of insightful stuff with a single system that's a workstation. So now you pick a time column. The time column is the date. But if you don't know which one to take, if there's multiple time columns, you can do auto. It will automatically find that for you. If you say you want to look for it, and there is time, it will find it. You can also pass a weight column. That's what Sri was showing. This is a sample weight. It says weekends matter more, because more people buy stuff on a weekend, for example, or a holiday for Christmas. You don't want to have your store be not stocked for Christmas, right? So compute those better. So put a higher weight there. So somebody made a weight column that we can consume. There's also a fold column. The fold column would say, keep points from the same group together. So San Francisco is training and New York is testing or validation. Don't mix them up. You can separate your data by providing a fold column that says how they should stick together. Otherwise, it would be cheating if you knew, if you train on San Francisco and you scored on San Francisco, that's not fair, because then you can learn to get better at it, but you're really, in reality, never going to see the same city again or something. Like there are scenarios where you want to split your data such that you only have other stuff in testing. That's for advanced users, but there is all these options. So now that you're on time series, I just say go. Maybe I'll turn down the accuracy a little bit, just make it a little bit faster. What you will see is that it automatically finds stores and departments as grouping columns. And as this is running, you see the dates, department, and store are the three things that it lists here under time group columns. So it finds out that there is separation of time series. And each separate time series is fitted automatically by a gradient boosting model that does groupings, aggregations, SQL-style grouping aggregations, means over the time, exponential smoothing, moving averages, lags. Lag is a past value, right? The store sales from a year ago matters, so that's the target lag of department store 52. In this case, 40 weeks ago matters. And you see this plot of actual versus predicted that Leland was talking about. So you get a sense that we get most of it. However, there is some heteroscedasticity, so that the right side or so is maybe a little dispersed, so the really big sales numbers are not good yet. And later it'll get better.
One of the questions is, can I run Driverless AI from Python?
Yes.
Maybe
yes.
the docs while it's making that.
So let's spend the last 5 minutes now on questions only, so let's prioritize that. I just want to make sure that you understand the implications of time series. So yes, of course, this whole GUI is auto-generated from Python. So there is a Python GUI that you can, a Python client that you can type in the same commands that this GUI is issuing to the server. So your laptop could talk to this instance on Amazon from here, and you're in the client of Python saying, hey, please upload this data set. Hey, please run this experiment. So you go to help. The help, by the way, if you don't remember what I just did, was under resources. help. If you go there, oh, sorry, which one was it? Here, this one. It will get you to the right version, and it will show you all the documentation. That was the link I mentioned earlier, docs.h2o.ai. It's also in the product. So the product itself is shipped in the software. So now here you can go down and you can look at everything. At the bottom it will say Python client under Appendix A. How you install it. It's basically a pip install. And then you can run all these different experiments. Everything is a command. We'll also have an R client for those who've asked. There's also a Java client, work in progress. Basically, it's just issuing remote control calls, right? The server needs to just know what to do, as if somebody clicked on the GUI. You can run on any cloud. We are cloud neutral, Amazon, Azure, Google Cloud. You can run on-premise, native, RPM packages, Debian packages. You can run Dockerized, so you can take your Windows laptop or your Linux or your Mac laptop and run it on it in a Docker image, for example. You can run it in the Linux subsystem on Windows 10. You can run on workstations, on DGX, NVIDIA supercomputers, on Power, IBM Power systems. If you want to run it somewhere and you can't, tell us. We'll make it possible, most likely. There's a lot of things that you can do. The code that's generated is always standalone artifacts that are running everywhere. So it doesn't matter where you train your model, out comes a Java pipeline, and soon a C++ pipeline that will be standalone. You don't need Driverless to put the model in production. Driverless makes the production code that you put to production. It doesn't yet have a distributed mode. That's what we're working on. That's on the roadmap. Distributed means you can have 10 people run on a 100-node cluster and then just run experiments all day and night in big data experiments and so on. That's work in progress. We have prototypes, but it's not shipped yet. Can we show some more questions? Yes, there's diagnostics that show you the residual chart that we mentioned earlier, by the way. That's a nice one. So if you predict something like a numeric value, let's say we want to predict for the credit card data set, we want to predict, actually we just did Walmart, right? We should be able to see that on the weekly sales model here. We can diagnose it. We diagnose it on the test set. Now we'll see the store sales as a function of the actual store values that we have. Here is the residual plot. So the actual versus predicted shows us what we saw in the GUI earlier. We get most of the store sales right for the different departments and stores. And you also see the residual plot. It's nice. It's not as heteroscedastic at all. It looks pretty good. It means there's basically nothing we can do now but to look at the data some more and see if we can get rid of some outliers or maybe understand what's driving the errors. But this is a pretty good model. It has also good rankings on Kaggle. If you were to submit this is also a Kaggle problem, a challenge, because it figures out all these different groups in the data and the lag features that matter. So in this case, this was a simple model, but it says 1 year ago matters the most. But it at least grouped it. Now, sometimes you get way more interactions, right? If you turn interpretability down to maybe 1 or 2 or 3 or 4, or even let it run longer, it will find something else. This is also a small data set. Sometimes in small data, we're more careful not to do all this feature engineering. So all the demos we do kind of doesn't show the value of driverless because we say there's no point in doing this crazy stuff because it's small data. You don't want to overfit with all these weird transformations that do it this way, right? If you can just look at it straight. So for bigger data, these transformations sometimes make more sense. You don't need to make your training and validation splits by hand, but you can. So if you're a data scientist and you do not know how you should do these splits, that's a problem. Then you're not a data scientist. Then you're a clicker, right? You need to think, what's my data? What do I want to achieve with it? How do I get that to mean something for my business? The data that I'll get in production is not the same data that I have now. There's some records from the database that are like updated in real time now and joined back in, and then I'll get that data set as if it was in the past, but in the past actually it was different. You need to think about that kind of stuff. If the data that you're presenting to the model is the same that you'll present to the model in production, and every row is independent, and it's just like measurements of t-shirts, and you need to decide what kind of t-shirt it is, yeah, sure, that's IID. You can throw it in, just the training data. We'll split it up automatically. We'll figure out everything. But if suddenly that stuff is all changing, it's like time series for a hedge fund, and you want to predict the future, you can't just blindly throw in all the history and say, fit, and then what happens tomorrow? Lots of people say, well, can you predict the stock market? Well, yeah, sure. To what degree of certainty, though, right? So the question is, do you understand your data? So yes, you should think about it, and if you know that the validation split that you provide is different than the training, then do that. Otherwise, we do a pretty good job at splitting it. If it's pure time series, we'll do a really good job at splitting it. If it's pure IID data, which is like the same distribution, and we'd also do a really good job. The hard stuff is the stuff in between. It's kind of like time series, and it's kind of like all the same. It's just not quite. It's this fall versus spring. And in those cases, it does help to make a validation set or to provide a fold column. It doesn't integrate with Spark, but it does. So the production code can be put into Spark, and you can score the Mojo, the artifact, the Java artifact in Spark. That means you can score in Spark. But it doesn't run as part of Spark right now. This is a self-contained training instance. We cannot make custom loss functions yet, but we will provide some ways to do that. You have to understand there's different loss, there's maybe 5 different loss functions used in this product, right? One is the one that we score the models on, one is the overall optimization goal. There's each model, whether it's TensorFlow or FTRL, they have their own early stopping criteria and so on. Then there's the reusable holdout scorers. They all have certain things. We cannot let you control all the code for all those inner guts. But if you say, I really care about this particular metric, especially for binary classification, the true positives, false positives, this kind of bake-off, that is very easy for us to add and say, okay, you care about that. We already have a lot of that in the tool, by the way. If you don't know, you go to the experiment for binary classification, and you can already play with the ROC curve here. You see the different thresholds. It shows you the point where there's the best MCC or accuracy or F1 score. We have precision recall curves. We have lift curves that show you the cumulative lift. If you send an email to the 30% of the population, how many times better are you than random? This kind of stuff. It's already there. We have a gains table that shows you what you capture. If you send a letter to 50% of the people, you get 80% of the responses that are captured, right? All this stuff is already there. So a lot of metrics are there. You can also see it on the validation or the test set. You can switch between the test sets. Let us know if you have any other questions. It scales to, I would say, tens of gigabytes for sure, sometimes hundreds of gigabytes, depending on your instance. If you have a 1 terabyte machine, it's better. If you have a laptop, of course, you can only handle maybe a gigabyte data set or less. It depends also which model you're using. If you do FTRL, it's a streaming algorithm that we added recently with Alexi's help. That's an amazing algorithm that is less memory use hungry than, say, a GBM, right? So you can tune it. That's why you should play with it, ask us for questions. We don't just do ARIMA or not, or just GBM or not. We do all of it, right? But for time series, we have something that we think is better than ARIMA. But we do hear you. We want to put ARIMA in as a citizen and have a point on the map that says, this is ARIMA, this is GLM, this is us, right? So you can see quickly how well we're doing. Currently, we basically just do well, and then you need to figure out that that's true. But the hope is that we can show you how well we're doing out of the box.
Lots of amazing questions, actually. Fun feedback for future roadmap items. ARIMA is one of my own top requests as well. So these are all, the advantage of driverless AI architecture is much more easier to plug new algorithms reasonably. So the long-term path here is convergence between both open and closed source platforms. So you can start, one question was around, can I get my Mojo code just like Java code or Python code? I think using Driverless AI as the configurator for your open source usage of H2O3, that would be the obvious ask. A lot of customers have asked us, analysts have asked that. So a lot of good, fun feedback for 2019 that we can take in from you, and don't stop asking questions on Slido. Continue to ask questions today, tomorrow, but continue to have a great partnership with us as we build the product out the rest of the year. Thank you, Arnav. Fantastic hands-on session. I'm hoping everyone on the floor, or at least most everyone on the floor, have tried to run the product and then gotten one model built at least. And there's no way to build only one model in this product, right? It's automatic modeling.
We'll add that later. So H2O3, for example, has AutoML, right? So there should be a button that says run just that, or compare my driverless model with AutoML, compare it to an H2O GPM or random forest. So we hear you, we want to put that in. It just takes time. But definitely we want to build H2O models in driverless, and we want to put driverless to make a recipe that you can just take as open source and run on a Spark cluster.
That's a good question. Can I see the iterations you're going to run before, like a plan? I want the explained plan of the product before you run the entire benchmark. I think that's a very good one. We are working on some of those similar features. Let me quickly bring two folks to the stage. First one who built Aquarium in record speed from the last H2O world to this H2O world, the one that you used today, Tom Kraljevic. Thank you. So, training on AI, that's kind of, there's probably separate companies that work on training in labs and whatnot. But one of the things we ran into in H2O London was we had the largest single workshop attendees ever. And I think we beat that number today. And when we had that, I said, Tom, let's take the quick labs out and give something good. And here we have Aquarium.
Yeah, we beat it by over 150 today, actually. So thank you all for coming. It's really, really great to see these events getting bigger and bigger, and just more and more folks getting their hands on the technology and being able to learn about it and to use it. And hopefully we'll keep on growing. So
Tom built the first versions of H2O, took it to market, got it installed in several of our customers. Any highlights from that? This afternoon we have H2O3 hands-on workshop, right?
Yep, this afternoon there will be H2O3 as well as sparkling water for hands-on. Everybody is, of course, encouraged to go through those. We have a few presenters that are very familiar with working on the code base and bringing it to life. So,
and there is AutoML in open source, right? Our commitment to open source is just as strong. So you'll see that in full display rest of the afternoon. Let me also invite our second kind of honored fellow from H2O on stage, Josephine Wong. Tom and Josephine have been pillars of the company as well as the community, and most of you have heard from them or seen them in action or worked with them. And I think there is a stat somewhere, maybe a fourth of the audience in attendance is Josephine's invites.
Thank you, everyone, for coming.
What do you want to say to the audience? The first H2O world was really, maybe that section. And since then, we have grown the company and the team and the community. How does it feel?
This is an amazing turnout. Record numbers coming to this event. I hope you found this morning's sessions as inspirational as me to see all the new product enhancements. I hope you enjoyed the driverless AI training and the training this afternoon on the core platform. Tomorrow is also going to be unbelievable. We have a phenomenal lineup of speakers from the community and our customer base. And we just really appreciate your time, and feel free to reach out to any of us if you have any questions on any follow-up.
Tom?
Yeah, I would just absolutely second that. And tomorrow, I think we're going to have even more of a packed house, which is just fabulous. So looking forward to talking to many of you over the next couple of days. And thanks for coming, and thanks to the team for putting together such a great product. And
yeah, H2O World is a immersive community, right? This is your event, not just ours. So take the kind of 24-hour cycle to get as many innovative ideas that are floating around, bring them to us or spark them. I have met quite a few other startups in the audience walked up. Feel free to, it's better to raise a whole forest than one tree. So ours is an ecosystem thinking. It's not of, AI has been a data science has been a movement for us as opposed to a true corporation. So we think of this as more as a community building exercise as opposed to a enterprise building. So we're really excited about your attendance here, but we want to bring new people into the fold so you can start giving as much and getting as much as you can from our work. So looking forward for the collaboration. The two H2O fellows, first one from business side, and Tom has been the bedrock of our engineering excellence over the years. So feel free to run up to them and give as much feedback as you could.
And we really do want your feedback, your honest feedback on all of the platforms, products, features, functions, anything you're looking to do in the future. We're here to enable you. Thank you.
Big up. Congratulations.